I am Sajida Sanghavirasimha. The real world problem I chose was the manual data collection. Right now, media managers spend hours reading through messy XML RSS feeds to find specific articles about nature and wildlife. Doing this by hand is slow, causes mistakes, and lead to duplicate data. To solve this, I built an automated ETL pipeline, which stands for extract, transform, and load using Apache NiFi. My design perfectly demonstrates the movement transformation and processing of data. Let me show how it works. First, let's look at the data movement. To make the system highly scalable, I used the fan-in design pattern. Instead of hard-coding one website, I created 4 different triggers for websites like BBC and Science Daily. They all send data into one single HTTP processor. This means we can easily add 100 more websites without changing the main pipeline. So then the data transformation part is the pipeline takes the raw XML and splits into single articles. It extracts the text and create a unit ID for each article. Then it completely transforms the messy XML into clean JSON format. So finally we have data processing. I use rules to filter the data, only allowing articles that mention words like nature or wildlife. So you can see it here. And I also use stateful processing with the memory cache. This gives NiFi a memory so it can remember the unique IDs of articles it has already processed. This is the code server I have used. Then let's see it in action. You can see data moving through the visual quiz. NiFi natural uses back pressure. This is great architectural feature because it stops the system from crashing if too much data comes once. So, so these are the output folders and accepted duplicates, errors, invalid, unmatched. And if we look at the output folder, we can see the results also. The unstructured XML text has been cleanly transformed into a perfectly formatted JSON. It can be used anywhere and after saving into a database. I want to highlight two main architectural strengths of my design also. First is duplicate detection. The system just pulled the data same again because our cache memory it detected the duplicate IDs and routed them safely into a duplicates folder so we don't spam our database. And second is the fault tolerance. If bad data enters the system, it will not break the pipeline. It routed all failure paths to a specific error folder. The pipeline will running safely. You can see it in the here also. In here, the each failures, errors, retries, all are redirected into the errors folder. So then to conclude this project uses infrastructure as code. I exported the whole pipeline as a JSON file. So we can back up into GitHub and can easily rebuild on any server in any seconds. And thank you.